All right. Well, thank you everybody for joining. Very happy to see everyone. I have an excellent set of guests today. Today I have two base layer projects. So Dieter, you're working on Flow blockchain from Dapper Labs. Monica, you're working on Cadena, of course. And I also have Peter from Props. Props is a little bit higher up in the stack, but they've done a ton of work almost as a client of the base layer across many different base layers until they've sort of converged that they have.
Uh-oh. Is everybody else still there? Oh, no.
I think we lost Jake.
All right. I'm going to take over this panel if Jake doesn't come back. Peter, can you explain to everybody in like 2 sentences what your project does?
Sure, yeah. So Props is effectively like a loyalty token that we offer to mainstream consumer apps that want to like find a way to kind of incentivize and drive retention, revenue, all the normal things that these consumer apps want. They want to give them something as a way to reward them and kind of establish that loyalty. So whereas Jake mentioned kind of more at that application level, and I think kind of why I was invited here is like he mentioned, have been shopping around, trying out different layer ones and thinking about kind of what matters there. We actually have a two-chain architecture. So from the get-go, we kind of had our own layer 2, a side chain that we built, and that was on top of Hyperledger Sawtooth. And I can give some war stories and some scars on that topic if anyone wants some fun.
I definitely
there.
want to hear some of those.
And then recently kind of started working with Algorand. So we're an Ethereum-based project and token. That's where the core logic lives, and I can kind of go into that as well if anyone's interested. And then switch the layer 2, or are switching the layer 2 over to Algorand because running a layer 2 isn't necessarily kind of our core premise, and it's also kind of a way to test Algorand and see, okay, you know, before making a much larger leap of where the core protocol should live. So haven't yet switched away from Ethereum, and you know, I think there's a high barrier to doing that. Ethereum obviously has the kind of the territory there, but starting to think about kind of our needs, and it's also interesting that these, you know, the line between layer 1 and layer 2 is kind of a little blurred in the sense of a lot of these layer 2s allow Ethereum assets to go over there and be traded quickly, and you can in some ways be using what's, you know, positioned as a layer 1 for similar things, especially as assets begin to move between many chains. So I think it's all a little blurred, and that's kind of my background and perspective.
Awesome, thanks. And sorry I dropped off. I think my connection is okay now. Monica, do you want to give a quick intro to yourself and Cadena? And then we'll go to you, Dieter, afterwards.
Yes. I'm maneuvering things so that I can see the screen better. How about Dieter goes while I mess with my screen?
Okay,
Sorry.
no problem.
This is the home office trouble.
Yeah, so I'm the chief architect of the Flow blockchain, and Flow is the blockchain we wish somebody else would have built for us. So you know, if you don't know the background, I was the chief architect of CryptoKitties. Worked with that team building on Ethereum. Obviously, we had a bit of an interesting experience on Ethereum, sort of pushing a network that was pretty close to its limits, right over the edge. And so we did a ton of research to try and figure out what a better blockchain might look like, and we decided that all the best pieces were in different blockchains, and we wanted to try and build something that brought it all together. And I think the big thing that differentiates Flow from a lot of the way that blockchains think about themselves is that, you know, I think Ethereum and a lot of blockchains are best described as, you know, economic systems that have the capability to do computation. And we really designed Flow as a computation system that has the ability to manage economics. And so just as a simple example of how that comes up in Ethereum, when you want to breed two kitties together, what you actually do is use, you know, or if you want to transfer a kitty from one person to another, what you actually do is send 0 ether to the CryptoKitties smart contract, because that's the verb of Ethereum, is send ether. And then you attach an extra message saying, oh, and actually, even though I'm sending you 0 Ether, what I actually want you to do is transfer this kitty. Whereas in Flow, every transaction is a little program, and that program, one of the data structures that you can manipulate is a token. But you manipulate that with code the same way you would manipulate any other data structure. And so we think that some of the most interesting use cases of blockchain are going to come when they're more like general purpose computation devices rather than economic systems that have some computation ability. And so we're very excited. We're running things internally now, and we'll be launching for other people to run on top of it very shortly.
Great introduction. Thanks, Dieter. What about you, Monica? A little background on yourself and Kadina.
Well, the most interesting panels come when people are disagreeing with each other, and so far this is going to be really boring because I'm just going to say more of the same things that you guys have already said, which is that we decided that we needed a better tool than what other people had built, so we built our own tools. And in fact, we started off by creating a smart contract language and a private blockchain, and then we created a public blockchain, and now we have a single platform that allows you to write code that acts as computation, not necessarily just moving around money, in a simple smart contract language on either a public blockchain, a private blockchain, or both at the same time, and help them communicate with each other. So we're a scalable layer 1 proof of work protocol, and then we also have these other components, the smart contract language, the private blockchain, into a single platform. And we have been up. Mainnet launched in October 30th of last year. We've been up for 6 months. We have another hard fork coming next week. We're currently testing the expansion of the network from 10 parallel chains to 20 parallel chains. Our IDE is out, and you can use it to write easy, simple smart contract code that has full formal verification of all user code. And we're just pushing it out there. Just announced a partnership with Chainlink. We're trying to get people to use the thing that we've built that we originally were like, wait a minute, we can make this way better. So I've agreed with like the things that you've said, which is that we need better programmable money, and layer 1 protocols that we had are difficult, and we need better tools.
Great, thanks, Monica. So I think what I'd like to do is across these 3 projects, what I'd like to do is break it down in terms of the issues. And the issues, we don't have a lot of time, but the main 3 issues, the way I see it, is scalability, interoperability, and maybe go to market, right? And so let's start with scalability. Can you guys talk a little bit about, especially Monica and Dieter first, since you're the base layers, can you talk about like how you achieve scalability in your systems?
I mean, for us, we just had this idea that if you can have one transaction at a time, why not have multiple transactions at a time? If you could have one blockchain, why not have multiple blockchains? And so we literally have 10 blockchains that all generate blocks all at the same time, but then they keep tabs on each other by sharing proofs with each other in this complicated expander graph structure that would take me too long to explain on this, but and so because we have multiple blockchains running at the same time, we can process more transactions. It's not that complicated.
Great.
So when we were taking a look at other blockchains, we realized that the vast majority of them either did some sort of state sharding, which is really the more common solution, or they limited participation in some way. And we really were super allergic to participation limiting, but we also were really concerned about the state sharding. And fundamentally, we think that some of the coolest stuff that's happened in blockchains, including things that were built on top of CryptoKitties, were when one smart contract was talking to another smart contract. And in a blockchain context where you're paying a premium, like definitionally, you're paying a premium to have a computation done in an environment because the blockchain has special features. And one of those features is typically, atomicity. The idea that, I don't know if James is still in the audience, but James Prestidge put it as you get an atomic lock on the whole state. You get for a period of time, you get the whole blockchain state, and you can sort of do whatever with it you want. And the power of that is, from a programming standpoint, is truly remarkable. And we see it being leveraged in all sorts of interesting ways. And that can't happen in a sharded world, or the ways that it can happen in a sharded world are very awkward. And so we wanted to find a way to not limit participation while still achieving scalability, while getting it.
Participation, when you say participation, that doesn't mean anything to me.
What's that? Sorry?
What you keep using the word participation, and I just wanted you to explain that while you were saying the thing that you were saying.
Oh, sure. So that's the notion that the requirements to participate in the network, meaning running a node, are arduous, right? So you need to have a data center, or you need to have like an 8-core machine with multiple gigabytes of RAM, that sort of thing. So saying that the only way to run as a node in this network is to have a very large hardware commitment, as opposed to something like Ethereum or Bitcoin that have always wanted to make sure that people who are operating nodes can run on relatively modest equipment that's available to most people.
Got it. Cool.
And so we wanted to make sure that the network was governed by nodes that could be run on consumer hardware. But obviously you can't then ask the people who are running that consumer hardware to process all of the transactions. And so what we did was we built a system where we separated the blockchain into, you can almost think of it as like, where sharding, you might think of it as like vertical layers. We sort of did it in horizontal layers. And instead of saying, hey, let's have lots of different blockchains all doing the same thing and talking to each other, we said, let's make up a blockchain with different layers. And then we can make a different scalability versus decentralization trade-off at each layer of that stack. And so what we have is we have the consensus and verification process being run in a very lightweight way. And so almost anyone should be able to participate running consumer grade hardware as one of those kinds of nodes. Whereas we have a set of nodes called execution nodes that are given a list of transactions and told to process them in linearizable form. And the output of that is deterministic. There's no power, there's no influence that an execution node can have over what that output is. It can just say, hey, I did all of this math and this is what I came up with at the end. And as part of that, it's generating, interim states where it said like, well, I did 10 transactions and I had this result, and then I did 10 more transactions and I had this result, and so on. And then those verifiers can each check a little piece of that computation. And by induction, you can see that there's no way to introduce an error for an execution node to introduce an error in that computation. Somebody somewhere sort of catching that error and being able to say, no, you made a mistake here, and resulting in the execution node being slashed. So it shares a lot of properties with optimistic rollup, except that one of the big differences is that we've taken a lot of most optimistic rollup schemes don't have really great guarantees against the verifier's dilemma. And we put a lot of effort into making sure that by integrating this sort of secondary execution environment, or the specialized execution environment maybe is a better way of putting it, that we had verifiers that were checking their work, and that those verifiers would get paid even when the execution nodes didn't make mistakes. And so we worked around the verifier's dilemma in that way. And so, so fundamentally what we're doing is we're saying we're going to have different computers doing the consensus, then do the computation, and then we're going to have some other computers that are watching that computation result and making sure it's correct. Monica.
Hi. Is this a proof of stake system?
Yes, it is.
Okay, that's why I was so confused. I was like, what's going on? I could have used that qualifier at the beginning.
Nice. Thanks,
yeah,
Dieter.
Sorry, I apologize. It absolutely is a proof of stake system. Yeah.
Great.
Let me take it over to Peter. So Peter, scalability is like one of the reasons why you guys have had a lot of candidates for base layers instead of just maybe like staying on Ethereum. So can you talk a little bit about, like what role does scalability considerations play in props, and how you sort of got around to the base layers that you did?
Yeah, it's obviously really important, and we were kind of lucky actually that we kind of followed CryptoKitties and were kind of designing as that was happening. And it kind of helped to shape us to kind of know that we needed to kind of keep these things in mind from the beginning. And we kind of essentially have two types of transactions. Like I think there's a, not everything is universal. So we have these like high volume, low value transactions that are happening where the apps are doing these micro transactions to the users. And these have different properties around the like storage of the core asset and the operation of the protocol that is kind of happening is a lot more high stakes and can happen and can have higher fees, for example. So we kind of split it into two where we can have like lower security properties and maybe like a separate system for the bulk of these transactions. And then this process to kind of summarize those and bring it to somewhere like Ethereum where you can have kind of less scale. So obviously, scale is really important. Like I think it's kind of interesting hearing some of these scaling proposals, like with Flow. Like I'm curious, how much more scalability kind of do you get? Because definitely one of the things we find is like you have these other chains where it's like, look, come to our chain. It's a lot cheaper, and we have some degree of additional scalability of Ethereum, but like to some degree they have that scalability because no one's using it yet. And if enough people kind of went over there and started using it, then you just have the same problems. And so, and I guess the other thing I'd say to Dieter is like, obviously the composability is like really cool and really important, but there's also like something not right there in the sense of like when you have two completely separate applications that just, our application couldn't care less what's happening with CryptoKitties. And so there just seems something fundamentally inefficient by the fact that those two are sharing that kind of access to the same state at any given time. And so it's something about that design, while I kind of love the composability argument, and that is one of the coolest things that's come out of Ethereum, it doesn't seem like that's like the scale. Like, and I'm curious, is there, or Monica?
Yeah, I mean, just to briefly touch on the composability part, the thing with composability is that there's a mathematical term. It's commutative, right? Like, so like CryptoKitties, you're like, well, CryptoKitties, that doesn't need to be on the same shard as props. But obviously CryptoKitties needs to be on the same shard as DAI because like lots of people are going to use DAI, or CryptoKitties needs to be on the same shard as OpenSea because lots of people are going to be trading, their kitties using the open market on OpenSea. And then OpenSea clearly wants to be on the same shard as, as blockchain cuties or My Crypto Heroes. And then, well, maybe My Crypto Heroes, has a plugin, right? Like, and the problem is that you always have these chains where it's like, well, okay, maybe people don't want to use props to buy CryptoKitties, but maybe they do. And even if they don't, there's probably something in the middle or some chain of things where it's really important for props to be on the same shard, to get most efficiency to be on the same shard as X, and X wants to be on the same shard as Y, and Y wants to be on the same shard as CryptoKitties. And you can't have all of those chains. Somebody has to break the link somewhere along there. And so, the way I think of it is that, before we decided that we were going to build our own blockchain, and we were just doing research into a bunch of different blockchains, there were a bunch of people saying, hey, we're building a games blockchain, right? We want a games blockchain. And I recoiled at that idea. I don't want to be, I want to build games, but I don't want to be on a games blockchain, right? I don't want to be in that world that's separate from everything else. I want to be connected. And that was part of where it came from is that, games are hooked in right now today, right? There are tokens that use CryptoKitties to create a fungible token that are tradable in Uniswap, right? So even that you'd think the DeFi world and CryptoKitties aren't connected, but they are because Ethereum isn't sharded right now, and because those connections can exist, and people do find value in creating those connections.
So what's going to happen with Flow is like, do you need DeFi to move over there? Or obviously, like Ethereum and Flow will almost be like two shards that they will, you'll need DAI to be able to jump over, and maybe you'll have like a separate, like, isn't it the same, like multiple blockchains is almost like the equivalent of multiple shards in a way, where some things are going to have to kind of lock here and use over there, right?
You're absolutely correct. I think that it's going to be very painful for, we're looking into that now, right? We have a bunch of customers who are locked into Ethereum because they have CryptoKitties. We want to build a new version of CryptoKitties on Flow, and how do we bridge that, right? That's a real big problem. And if the sort of ceiling on the limit of the throughput of Ethereum wasn't so low, I think that we would just say, well, look, like, even if it's expensive, even if we do have to put some things in second layer, it makes sense, right? The network effects and the number of people are there. But the number of people that we had playing CryptoKitties successfully during that first month was very small from the standard of consumer applications, right? We had maybe 10,000 people that were able to play CryptoKitties daily actives, and we had 1 million people trying, right? Like, we literally had millions of people coming to the website and bouncing, and obviously some of them just didn't want to install MetaMask, but some of them tried, and they had transactions that would take a week, and you can't build a consumer app when you're limited at that level. And even if layer 2 gives you a 10x or 100x, you're still not able to have millions or tens of millions of users executing on that chain. And so I think that you're right in the sense that, like, anybody who's on Ethereum is going to have there's going to be difficulty in bridging, and we're working really hard to make sure that, at least for our users, that there will be some way of solving that problem, and hopefully solving it in a more robust way, so that any Ethereum applications might be able to bridge. But I think there's a big difference between being able to bridge some assets sometimes, and wanting to have those things interact all the time. And so it may be the case that there's never a big DeFi presence on Flow, because that Ethereum is acceptable for that purpose.
Mm-hmm.
But I think there's some other features about Flow that make it really great for DeFi. But I mean, that's ultimately that's going to be the market's decision, not ours. But for the kinds of apps that we want to build, we really want to make sure that people are able to interact with each other, and that smart contracts can talk to each other without having a bunch of complexity around asynchronous communication.
Thanks, guys. It's a really interesting discussion, and you guys have sort of naturally segued into the operability side of things. And so let me go to Monica now, kind of on the topic of interoperability. So what we see in the market, and you guys have alluded to this, is like, in practice today, the vast majority of sort of developers, DeFi activity, NFT activity, right, happens on Ethereum. And when people are building new base layers, it's natural that they want to bridge into kind of the existing world and maybe create new facilities. So, Monica, I know you guys have launched something called Kadena Mint.
Yep.
Can you talk a little bit about how you're thinking of interoperability with other base layers? What does Kadena Mint do? Do you have Ethereum integration as well?
Well, our theory is that we want our smart contract language packed, which we think is absolutely the best thing, and everybody should be using it. We just want everybody to have access to it. So we've been doing our best in order to make packed interoperable with everybody else's blockchains. And I'm making the rounds and trying to make it all happen, because the amazing thing about packed is it's super simple and composable, and the entire thing you can formally verify, and we think that it's an amazing tool. So ICF, we've been working with them. They gave us a grant, and we produced a version called Kadena Mint, which is basically our smart contract language on top of Tendermint, which can then talk to Cosmos. And then we're also working with the Web3 Foundation, and we're putting Pact on top of Polkadot. So you can either run a parachain, or we're discussing different implementation methods right now about which way we think is going to be the best way to put it out there. We're actually going to put a request for comment out like in a month. But the idea is, if you can write Pact in a smart contract, and then you can connect that to another chain, you can do that all inside the Pax smart contract layer, and you never really have to leave. You can send a Pax smart contract to some kind of outside oracle, which can then connect it to another blockchain. And from a programming experience, it's going to be relatively seamless. So we're working on some hybrid blockchain projects right now on the Tendermint side. So that's the goal, where I want to be able to actually see people not have to worry about like, well, if I have this thing, then go and then save this here and then make this call to this other external source here. And then, then I'm going to have to make sure that I have tokens in this wallet over there. We can make this a much more holistic, integrated experience. And we've already started down the path to that. I think we're going to see a lot more consumer power, a lot more choice for once people can move from blockchain to blockchain. We'll see the shitty blockchains that nobody want to use die because people can finally get their tokens off of them and put them somewhere useful.
Okay, thanks, Monica. And so maybe that's a good segue into.
Well, I think Flow sounds really useful. I think both Flow and Kadena are going to benefit from the possibility of people being able to leave platforms once we're interoperable that don't work, and for the ones that do serve their needs.
Well, but don't you also think that?
So basically, blockchains just become shards
in the
each individual blockchain is just a shard. And so what Flow is kind of doing is just making a big shard that could potentially host a lot of things, and maybe like I don't know exactly.
We're
how
also a
works.
big shard. We don't have the same issues with things.
But is it one shard or is it like many shards? All of your 10 shards.
Because for us, we don't actually have each chain maintains its own accounts, and you then transfer from one account to another, from one chain to another one. But you can treat the entire thing as if it's one giant computing ecosystem. And because you have to wait like 4 transactions, which is somewhere in the realm of like 15 to 30 seconds for verification of your transaction anyway, it can make the hops it needs in the times that you need to wait, because we're proof of work. You have like wait for validation of your transaction. And in that case, you can hop from chain to chain and it doesn't matter. It treats it like one big computer.
Mm-hmm. Thanks, guys. We have just a couple of more minutes left. We got until 3:20 Eastern time. For each of you, like people who are watching this, users, developers, supply siders, validators, etc., how should they engage your project? Where should they go? What should they read? Dieter, why don't we start with you?
Yeah, everything starts at onflow.org. There was actually a link in the chat that my friend Wei put up in response to one of the viewers' questions. But if you go to onflow.org, there's a lot of really interesting information there, including an interactive tool that lets you play with our programming language, which we think is best, called Cadence, that uses a resource-oriented programming model where you can mark certain data structures as representing objects of value, and then the runtime will actually protect those things and make sure that they can't be duplicated or accidentally dropped or counterfeit. So it's a pretty powerful programming model. We think lots of people have looked at it and said that they love it, but who knows? Maybe they're just looking at it compared to Solidity. But we think it's pretty cool, and it's definitely the programming language we wanted to use for building the kinds of experiences that we're doing today.
Peter?
Yes, if you're looking for a layer 1, can't exactly help you, although happy to share some knowledge of our research and struggles. But yeah, you can go to propsproject.com and find us. But if you know of applications, regular consumer social applications that kind of want a way to retain and engage their users better, you should absolutely get them to talk to us about.
And Monica, really quickly, where should people learn about Kadena Mint, all your integrations?
Go to Kadena.io. All the things are there. You'll find the Discord channel. You find the whatever. All the things are there.
Great. Thank you guys so much for your time and expertise.